Okay, so let's talk about two ways to solve problems that involve non-conservative work. That's work that doesn't conserve the mechanical energy. So imagine you have the following setup. You have a hill, and on the hill you have a box that's moving down the hill because, as always, you have mg acting on it, but also there's a friction force acting back on it, and always we have our normal force. And let's say we know that it goes down a height h, and so that means it goes down here, and at the bottom it has a velocity of v final, and it also, we know, the initial velocity vi. So if I ask you, what's the work done by friction, how would you do that? Well, there's two ways you could do this. One is you could just use the work kinetic energy theorem. And basically all that says is that the change in kinetic energy is equal to the net work done on the box. So that's the work of gravity plus the work of friction plus the work of the normal force. And the normal force is pointing perpendicular to the motion of the box, so we know that the work from the normal force is 0. So we just have work of gravity and the work of friction. And we can figure out how much gravity, the work of gravity, just from the change in the height. And we also know the change in kinetic energy because we know the velocities final and initially. So we could solve it this way. Or, since we know that there's only one type of work that's non-conservative, what that means is that the change in the mechanical energy is only going to come from the work from the friction. Or another way to put that is the change in kinetic energy plus the change in potential is equal to the work of friction. So that's another way that you could do it, because you also know the change in kinetic and potential, and so you could figure out the work from friction. And it seems like these are two different equations, but you can rewrite the work of gravity in terms of the potential and then get this equation. So they're actually both the same equation, just rewritten differently.